you don't have to do all that work of completing the square. You just look at the graph to write it in vertex form. Because, what is the vertex of this graph? 3, -4. Okay, there's a vertex. So when we write it in vertex form, looks something like this. We have our x. Go to the x value of your vertex. What happens to the sign? Switches. So +3 becomes a -3. Does the sign switch of the y value? Oh. Because it's on the outside, it just stays whatever it is. So there's that graph written in vertex form. Okay? We are now going to, and I'll get that pusher out of there. We're now going to reflect this graph over the x-axis. Okay, and I'm going to highlight some very distinct points that are sitting on the corners. And then we reflect over an axis or reflect over a line, kind of tap back into your geometry days. All we have to do is count. That's all I have to do. So I'm going to highlight the x-axis because that's what we're reflecting over. And just count. So I'm going to start with my vertex and count to see how far that vertex is away from the line we're reflecting over. So how far is the vertex? 1, 2, 3, 4. So then you're just going to go 1, 2, 3, 4 in the other direction. There you go. You're just going to do the same thing with the other point. This point is 1, 2, 3. You just go 1, 2, 3 in the other direction. Same thing with this one. 1, 2, 3. 1, 2, 3. What about these x-intercepts right here? How far are they away from the line we're reflecting over? 0. So are they going to move at all? Yeah, they're just going to stay right there. Whenever you have a point that's sitting on the line you're reflecting over, they don't move. They're just going to continue to stay there. So we did the points that are kind of underneath the line. Now we're going to do the points that are above. Same idea. Just count how far away. 1, 2, 3, 4, 5. We go 1, 2, 3, 4, 5. This guy right here is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then you just connect the nice U-shaped curve. And we reflected over the x-axis. And as you should have noticed in that activity, they literally took this blue graph and flipped it right over that line and made the red graph. Just flipped it. Oh, we did. And you can do that by counting. And we're going to label this G of X. So, yeah. Well, what's the vertex of our new line? Of the red one. 3, 4. Okay. Now we're going to write this equation in vertex form. So again, it's going to look something like this. C squared with an x. Again, what happens to the x value when we write it? If it's positive, it's going to turn negative. So that 3 is going to be -3. Does the y value change at all? Good. Stays a positive. So on the outside of that parentheses, it stays a positive. Here's the thing. What direction is our red graph opening? Down. And what did we say if it's opening down? What's out in front? It's maximum. What sign's out in front? Very good. A negative makes it a maximum. So we have to remember to put that minus sign out in front. Any questions over that? You might notice some differences between the original and the new ones. You notice what about our graph here, our equation is what? Negative, and the original one is positive. What do you know about these back numbers? Our back number is, and our back number here is negative. Some things to recognize. Well, now we're going to go back to that original graph, the blue one, and we're going to reflect it over the y-axis. Okay, so same kind of concept. You're just counting when you reflect. I'm going to go ahead and highlight the y-axis because that's what we're reflecting over. And you just count how far each point is away from the y-axis. Okay, so I always start with my vertex. 1, 2, 3. 1, 2, 3. And you're just doing that with each point. This side here is 1, 2, 1, 2. That point there is 1, 2, 3, 4. 1, 2, 3, 4. This intercepts 1, 1. This one's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This far point right here is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then what about this line sitting on the y-axis? Is that going to move at all? No. Whenever it's sitting on the line you're reflecting over, it just stays. And next, a nice U-shaped curve. And all we did is we took that blue graph, the original one, and we just flipped it over the y with the purple one. Like they're mirroring each other. Okay. So to write this in vertex form, no, oh, before we do that, sorry, jumping ahead. Label it. This is h of x. Okay. What is the value of h of x? Or what's the vertex of h of x? Negative 3. Negative 4. Now we can write it in vertex form. Okay. So if our x value is negative 3, what's going to happen when we plug it in? It's going to become positive 3. And then this is a negative 4. Does it change at all? Nope. It is a negative 4. Okay. Questions over that? Notice, too, here's the original vertex. It's 3, negative 4. When we reflected it over the x, the sign of which value changed? The y. Y value changed. When we reflected over the y-axis, which value changed? The x. It's kind of backwards of what you think would happen. So when you flip things over the x-axis, you're changing the y value to the opposite sign. When you're reflecting over the y-axis, you're changing the x value to the opposite. Backwards. Questions over there? Okay, some rules, and you might want to get that chart out from yesterday so we can fill these in. Whenever there's a negative on the outside of your function, that means you're reflecting it over the x-axis. When there's a negative on the inside, you're reflecting it over the y. Chart out. Now fill in those next two boxes. The same rules we wrote here. That should be in the middle. Go ahead, fill those in. So chart first box, you can say reflection over the x-axis. At second blank, you can say reflection over the y-axis. Okay? Again, this is just a nice reference. problems on your own. So take a look at the back. So it's given the function x plus 7 squared minus 8, write the equation that would represent a reflection in the x-axis in vertex form. Graph both to verify this in your calculator. Okay. So what did we just say happened when you reflect over the x-axis? Do we change the inside or the outside? The outside. The outside becomes negative. Okay. So when we do this, I like to think we have our original, and we just said the entire outside becomes negative. Okay? Well, you have to distribute that negative. Okay? So when we distribute that negative here, okay, and then we distribute the negative here. Right? It's super tempting to say, oh, the x becomes negative and the 7 becomes negative. But what's outside this parentheses that's kind of preventing that from happening? The square. So because that square is there, you can't distribute anything inside those parentheses. So the only thing we can do is just take that negative and tack it onto the outside. And then when we distribute that negative, a double negative becomes positive. So the sign of the 8 changes. So if we were to take that graph and reflect it over the x-axis, all you do is you just change the sign of the front, change the sign of the back. Nothing changes inside of the parentheses. Okay? So, hey, reflect this over the x-axis. You change the sign of the front, so it's positive, you put a minus sign. Negative, you put a plus sign. And then the back number, change the sign as well. But anything inside the parentheses stays. You don't change that. Questions? And I like to think when you're reflecting over the x-axis, you're making the whole function negative. So that's where you change the sign in the front, change the sign in the back. Questions over that? For example 4, it says given this function x squared plus 2, write the equation that will represent a reflection in the y-axis in vertex form. Oh, you forgot to grab the other one on our calculator. Cool. Go ahead and get out your calculators, and we'll just graph it to verify. Just to see, and using any calculators to do this might seem like a pain in the butt, but it's a good way of making sure you're doing this correctly. If it doesn't do what it's supposed to do in the calculator, then you know to go back and check your work. So if we look here, we're going to y equals, okay, we're going to go ahead and type in the original, x plus 7 squared minus 8. And then arrow down and type in our new one. We got negative x plus 7 squared plus 8. After we did reflect it. Okay. Go ahead, go to y equals, type that stuff in. And after you get it typed in, go ahead and hit graph. If you need help with your calculator, I'll give you time to ask. Okay. So the first one we graphed is the original, which is the blue one. There we go. Is it flipped over the x-axis? It is. Because we need to double check. We start here and count. Our vertex is 1, 2, 3, 4, 5, 6, 7, 8 from our axis. 1, 2, 3, 4, 5, 6, 7, 8. It reflected. Okay. So the great way of checking to make sure you did this right, use your calculator. Plug it in. It will tell you. Questions over there? So we go back to that box. When we reflected it over the x-axis, the whole function changed signs, right? We made the whole function negative. What happens when we're reflecting over the x? What just becomes negative? Just the x. So all you have to do to reflect it over the y-axis is you just make the x negative. And there you go. That's all you have to do. And that way it would reflect it over the x-axis. So let's go ahead and plug this in our calculator to verify. So we go to y equals, go ahead and plug the original x squared, that's plus 2. Now we're going to go ahead and plug in a new one, negative x squared plus 2. And hit graph. The blue one is the original, and the red one is the reflected one. Okay? Well, it's the same exact thing, and it did work. Couple ways to think about this. We go back to what we did here. If we were to clean this up, what happens when we square a negative? So negative x squared is just what? Positive x squared plus 2. What do you notice about these things? They're the same. This certain situation, it happened to work out that even if you did make the x negative, you're going to be doing the same thing. And you can also think about it. Okay? I'm going to go ahead and clear out the red one. And just graph the original. If we were to reflect the original over the y-axis, I'll highlight it. Here's the original. Is the vertex going to move at all? No, because it's sitting on the line you're reflecting, so it stays there. And if we look at all these other points, when we reflect, this guy's one away, that guy's one away. This guy's 1, 2, so when you count, it goes 1, 2. So it ends up reflecting onto itself. So sometimes that does happen because our axis of symmetry is kind of acting as our y-axis is acting as our axis of symmetry, and it's our line of reflection. So we're just reflecting it over itself. You saw the time you calculator. So that's why that happened to work out in that situation. There's other situations where that is not necessarily the case. Okay? This particular one, it is. Questions over there? Consider this function, negative x squared plus 4. What two transformations have occurred to the graph of x squared, which is our parent function, to produce our new function g of x? And again, we can verify it in our calculator if we need to. So I like to read from left to right, just like I would read a sentence. So what do you notice is out in front? A negative. What did we say when there's a negative out in front? What's it reflecting over? The x-axis. That's one of them. Again, if you need to, refer back to that box. When there's a negative on the outside, reflection over the x. Negative on the inside, reflection over the y. Again, I like to think of it as an opposite. Because what did we say f of x was the same as? Y. Right? So this is like saying negative y. So think opposite, we're reflecting over the x. Okay? Backwards of what you would think. Negative x means we're reflecting over the y. Flip-flop. Okay? So whenever there's a negative out in front, reflection over x-axis. If the negative's inside the parentheses with the x, it's a reflection over the y-axis. Okay, those are the two kind of differences. Then what happens? We're adding a 4. Is that 4 on the inside of the parentheses with the x? No, there's no parentheses, so technically it's on the outside. So when we're adding a number on the outside, what direction do we move? Up. Good. And we went up how many units? If it was plus 4, if it was like this, then we would say we would move left, because it's inside with the x. Here, it's not inside with the x, it's outside, there's no parentheses, so it's up 4. Okay? Here we need to go ahead, graph it in your calculator. Negative x squared plus 4. And then, oh, x squared. And then x squared. So the red one, the second one will be our original, and the blue one will be the new. So here's our new one. Here's the original. So if you notice, the red one flipped over that x-axis, and then it went up. 1, 2, 3, 4. So you know you did it right. So if you verify, and it's like way off, it's not supposed to look anything like it's supposed to. One graph's at the center and one graph's way over, not where it needs to be, then you know you need to go back and check your wording. Questions over that? One more. Okay, the graph of this function is shown below on this grid. Sketchy graph of both of them. The first one reflected over the x-axis, and the second one reflected over the y-axis. Before we do anything, we're going to write the equation of the original line. So again, to write it in vertex form, we need to know what the vertex is. What's the vertex of that graph? Negative 2 what? Yep, very good. Negative 2, 6. So we write it in vertex form. So something like that with an x. If it's a negative 2, when we write it with the x, it's going to become positive 2. Does the sign of the y value change? Oh, it just stays positive 6. If you notice, what direction is this graph opening? So what do we need out in front? Questions over that? Now all we have to do is reflect. Again, when we reflect over the x-axis, I'm going to highlight it. What do we just have to do? Just count. You take each point. Start with the vertex. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Plus point. This guy's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Same thing with the other one. The other one's 5 away, so you count 5 in the other direction. These guys right here are 2. So 1, 2, 1, 2. 1, 2, 1, 2. This point is 1, 2, 3. You count 1, 2, 3. 1, 2, 3. 1, 2, 3. Any questions over that? Alright. For the second one, we're reflecting over the y-axis, so it's the same exact steps as before, but we're just counting to see how far they are away from the y-axis. Start with a vertex, 1, 2, 1, 2 in the other direction. 1, 2, 3, 1, 2, 3. 1, 1. 1, 2, 3, 4. 1, 2, 3, 4. Is this point going to move right there? Nope. It's sitting on an axis. It's just going to stay right where it's at. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this guy's 1, 1. And all you have to do is just count. That's all you have to do when you're reflecting. Reflecting over the x, I'm just going to count to see how far each point is from the x. Count that same amount in the other direction. Oh, I'm reflecting it over the y. I'm just going to count how each point is from the y and count that far in the other direction. Okay, questions over that?